Okay, let's be real. Every React developer has been there. You build an app, it works, but it just feels a little bit sluggish. In this guide, we're going to cut through the noise, find the most common performance killers, and give you a clear playbook of patterns to make your apps feel lightning fast.
So, have you ever built something where you type into an input and there's that tiny, annoying delay? Or you try to scroll through a long list and it's just janky? Yeah, that's a super common problem. And 9 times out of 10, it's because your app is secretly doing a whole bunch of work it absolutely doesn't need to.
So what's the big secret? What's the main villain of our story? Well, meet the culprit, the unnecessary re-render. This is the silent performance killer in so many React apps. It's when your components are just redrawing themselves over and over and over again, even when, from the user's perspective, nothing has changed at all. Today, we're going to learn how to hunt it down.
Right. So before we can start fixing things, we got to understand what's actually broken. Let's take a quick look at why React decides to re-render a component in the first place.
So why does a component bother to re-render? Well, the first couple of reasons are pretty obvious, right? If its own internal state changes, or if the props it gets from above change, it makes sense to update. But that third one on the list, that's the real troublemaker. A component re-renders just because its parent did. And that can set off this massive domino effect where one tiny change at the top of your app causes dozens of components down the tree to redraw for no good reason. That's the cascade we need to stop.
So how do we stop that domino effect? Let's talk about some of the easiest, most high-impact fixes you can do right now. Think of these as the low-hanging fruit, the first tools you should grab from your performance toolkit.
Okay, our first anti-pattern is probably one of the most common mistakes I see. It's when you define an object or an array directly inside your JSX. Now, here's the key thing you gotta remember about JavaScript. The object theme dark is not the same as another object theme dark. They look identical, but in memory, they are two completely separate things. So every time the parent renders, it creates a brand new object, passes it down, and the child component thinks, hey, a new prop, I better re-render.
And here's the fix. On the left, in the bad example, we're creating that new options object on every single render. That poor chart component is just updating constantly for no reason. But on the right, we wrap it in the use memo hook. This is like telling React, hey, calculate this value once, and then just hang on to it. Don't create a new one unless you absolutely have to. Since our dependency array is empty, React returns the exact same object reference every time, and the chart component finally gets a break.
All right, this next one is going to look super familiar. It's the close cousin of our last problem. It is the same exact issue, creating a brand new reference on every render, but this time we're doing it with functions instead of objects.
See, it's the same pattern. On the left, that little arrow function is a new, anonymous function created every single time the component renders. On the right, we use the useCallback hook. And just like useMemo did for our object, useCallback caches the function itself. It gives us one stable reference so the button component down below sees the same on-click prop every time and doesn't feel the need to re-render.
Okay, so we've thrown around useMemo and useCallback. They're part of a core trio of tools, a memoization toolkit that every single React dev who cares about performance needs to have absolutely mastered. Let's make sure we're crystal clear on what each one does.
First up, use memo. This hook memoizes or caches a calculated value. The analogy on the slide is perfect. You don't redo your math homework if the numbers haven't changed. This is what you reach for when you have an expensive calculation, like sorting or filtering a really big array, and you don't want to do that hard work on every render.
Next is useCallback. Now this is where people sometimes get a little tripped up. It doesn't cache what the function returns, it caches the function itself. Its main job, its whole purpose in life, is to give you a stable function reference that you can pass down as a prop, which, as we've seen, is absolutely critical for preventing re-renders in child components.
And the final piece of our puzzle is React.memo. I like to think of this as a force field or a protective shield that you can wrap your entire component in. A component wrapped in memo will do a quick check. Are my new props the same as my old props? If they are, React will just skip re-rendering that component and its entire family tree. It's the defensive wall that makes useMemo and useCallback so powerful.
So here's where the magic happens, when you put them all together. You start by wrapping your component, say a user list, in React.memo. That's your shield. Then, in the parent component that's rendering it, you use useMemo for any complex data you're passing down, and you use useCallback for any functions. You see how they work together?
This three-part strategy gives your child components maximum protection.
All right, we've pretty much nailed down how to stop those sneaky re-renders. But what about a different kind of performance monster? Trying to render just a massive, massive list of data.
Just picture this for a second. 10,000 items. Imagine trying to tell the browser to render all of those to the page at the same time. Your browser wouldn't just be slow, it would probably just give up. Even if you tried them as super simple, the sheer number of nodes in the DOM will absolutely crush your app's performance. The solution is this really brilliant and clever technique called virtualization. And the idea is so simple when you think about it. Why render 10,000 items if the user can only see like 20 of them at a time? With virtualization, we only render the handful of items that are actually visible inside the viewport. As the user scrolls, we just recycle the existing elements and swap in the new data. It creates this perfect illusion that the whole list is there, but with a tiny fraction of the performance cost. And the best part is, you not have to build this from scratch. There are amazing libraries that do all the heavy lifting for you. For most cases, like a simple list with items that are all the same height, React Window is fantastic. It's super lightweight and easy to use. If you need something with more bells and whistles, like dynamic row heights, then React Virtualized is your go-to.
Okay, let's shift gears and talk about the cutting edge, the future of React performance. With React 18, we got a whole new set of tools called concurrent features, and they really changed the game for how we think about updates.
So what's the big promise of all this concurrent stuff? It's simple, to keep your user interface feeling snappy and responsive no matter what. It gives React the ability to work on multiple state updates at the same time, and more importantly, to prioritize them. So a big, heavy background task will never block the user from typing into an input. The main tool here is Start Transition, and it is genius. Let's walk through it. Imagine a search bar. When the user types a letter, updating the text in that input box is a high-priority, urgent update. It has to feel instant. But filtering a giant list based on that letter, that's heavy work, and it's not as urgent. By wrapping that filtering logic in Start Transition, we're telling React, hey, take care of the user's typing first, make that feel fast. Then, when you get a free moment, work on filtering the list in the background. The result? The UI never ever freezes.
And Start Transition is really just the star of the show. There's a whole supporting cast. The Use Transition hook gives you a handy is pending state so you can show a spinner while that background work is happening. Use Deferred Value lets you deprioritize a specific value. And Suspense opens up a whole new world for handling data fetching and loading states declaratively. It's a complete toolkit for building truly modern UIs.
So let's bring it all home with this final playbook. This is your cheat sheet. If your problem is frequent, unnecessary re-renders, your solution is memoization, using that use memo, use callback, and react.memo trio. If you're dealing with a painfully slow large list, the answer is virtualization with a library like React Window. And if your UI is freezing up during big updates, you need to look at concurrent rendering and tools like Start Transition. We have covered a ton of ground here, from the simple fixes all the way to the future of React. The most important thing to remember is that you have a whole set of powerful tools to fix these common problems. So the real question to leave you with is this. Thinking about the projects you're working on right now, what's the very first pattern you're going to try?